In this exercise, we are going to apply the method of cylindrical shells to find the volume of the solid of revolution that we obtain by rotating around the y-axis, the region that is bounded by the curves f of x equals 1 plus 2x minus x squared, g of x equals x over 2, and the y-axis in the first quadrant. Let us call the region that generates the solid of revolution region R. The right panel shows how region R generates the solid of revolution as region R goes around the y-axis. Let us first review the basic formula for the method of cylindrical shells. For a solid of revolution generated by rotating around the y-axis, the region that is bounded above by the graph of f of x equals y, and below by the interval on the x-axis that goes from x equals a to x equals b, the volume of the solid of revolution by the method of cylindrical shells is given by 2 pi times the integral from a to b of x times f of x dx. We obtain this formula by subdividing the region between the graph of f and the x interval from a to b into approximating rectangles. The factor x in the integrand represents a distance of the rectangular region to the axis of rotation. Since y is the axis of revolution, we can take this distance to be equal to any value x within the rectangle. On the other hand, the factor f of x in the integrand represents the height of the rectangle. Let us now examine the region for our exercise. We use an approximating rectangle for region R. The distance of this rectangular region to the axis of rotation is still equal to x. The rectangle's height this time is no longer plain f of x, but the difference between f of x and g of x. And so the integrand is now equal to x times the quantity f of x minus g of x. To find the limits of integration, we determine the intersection points between f and g. And so we equate 1 plus 2x minus x squared to x over 2. Multiplying everything by 2 and moving everything to the right side, we have 0 equals 2x squared minus 3x minus 2. Two x squared minus 3x minus 2 factors out into the quantity 2x plus 1 times the quantity x minus 2. And so the two curves intersect at x equals minus 1/2 and at x equals 2. X equals minus 1/2 is not in the first quadrant where region R is, and so we throw it out, so that it is only at x equals 2 where f and g intersect in quadrant 1. Because the graph of f starts out higher at y equals 1 when x equals 0, and the graph of g starts out lower at y equals 0, and because they intersect in quadrant 1 only at x equals 2, the continuity of both the functions f and g provides an analytical justification or proof that f is indeed the upper bounding curve and g the lower bounding curve of region R. Therefore, the volume of the solid of revolution equals 2 pi times the integral from 0 to 2 of x times the quantity 1 plus 2x minus x squared minus x over 2. Or 2 pi times the integral from 0 to 2 of x times the quantity 1 plus 3x over 2 minus x squared. We leave it as an exercise for the viewer to carry out the integration. The volume of the solid of revolution turns out to be equal to 4 pi.